Good morning, everybody. I'm really glad to be here, and it's really good to see such a big show up. I'm going to talk about a subject that I titled, It's a Small World After All. It's basically about the fact that in software development, as you all know in software development, I see this trend actually on all topics. It's like we're moving towards smaller stuff, right? You've seen that when you moved from waterfall to agile, that the cycles became shorter and the teams got smaller, and we see that we now do microservices and serverless computing. That means that the chunks of code that we write are actually going to be smaller as well. I'm going to try to show you a bit about what happens and why it's happening, and the fact that we as software developers actually have to deal with the fact that everything is going to be faster, and even faster than it is already today. So let me introduce you to myself first. My name is Sander Hoogendoorn. It's a Dutch name. I'm from the Netherlands. It's unpronounceable, I guess, in other parts of the world. I'm basically an independent dad. That's what I usually refer to as myself, because I have 3 kids. One of them is in the first row, and he came with me. And I'm also I'm a programmer. I've been programming for 35 years already. I do agile stuff. You have to do that right to make a living these days. And I'm not a certified Scrum Master, by the way. So as an independent consultant, I'm currently the CTO of a company that builds software for the Dutch insurance market. I used to be the CTO of an insurance company before that, and before that I worked at Capgemini, small company employing around 200,000 people around the world, and not only in the Netherlands, but, and this is my website, my Twitter handle, and my email address. I've written some books. It's basically on my slides all the time. Doesn't really matter. They're in Dutch. You won't be able to read it anyway. People in the Netherlands don't even read it. It's also there in German. That's basically twice as thick because they use longer words. And there's an English version as well of this book. I wrote a book on UML in 2003 too. I'm working on 2 new ones. Those aren't really finished. Actually, the topic of today's talk will be sort of in this book on the right, which I'm writing with my girlfriend Kim, who is not here today. So that's basically my introduction. So for another piece of introduction, do you recognize this album? You're all younger than I am, right? At least most of you are. Some of you will recognize it. This is the cover for Led Zeppelin 3. Now, I bought this album, I think when I was 11 or 12 or something. Yes, I'm an old guy. And on this album that we started playing, there's a song called Run Your Hour Stomp. You probably have never heard of it. I didn't either, and I looked at it the first time when I saw the sleeve, and I said, what is this? And I couldn't figure it out, because back then, when I was young, which is a long time ago, the internet didn't exist. Can you imagine the internet not being there, not being able to look up something on Google, or Google whispering in your ear saying, your next appointment is in half an hour? I couldn't, right? So I couldn't figure out what it was. I just named it Burn Your Hour. I didn't realize what it was until a little thing, the internet came up, and I could look it up on Wikipedia. That was already much better, right? But that was 20 years later. So it took me 20 years to figure out what it was, because it wasn't on any map. And of course, it's basically a small retreat in Wales. It didn't even have a map of Wales. When I was 12, I probably didn't even know where it was. So, and now I could look it up, and I could even find it on Google Maps. Or even better, I could literally see it on the satellite, right? So that changed perspective. The fact that the internet came up and that you could look up everything, and we do it all the time, right? If I'm in conversation with my son, we look up things all the time. I couldn't do that back then, right? And that is only like 30 years ago. So the world has changed enormously since 30 years. And that's a big change. Actually, I was in Wales a couple of weeks ago. That's why I'm bringing up this story. And I rented a car and I went up there. This is a small retreat where the members of Led Zeppelin lived for a year and a half, wrote a lot of influential songs. So I could actually visit the place, right? This is me at that place, somewhere on a hill in Wales, just being able to navigate there with my phone. And you can see me looking really, really happy. Doesn't make it much better, actually, but that's the way it is. So what is happening is that the times are changing. We all know that, right? The times have been changing all the time. But they are changing faster and faster and faster and faster. And that is something that, well, we probably don't always realize that. But I'll show you this graph. You all know this graph, by the way. It's Moore's law, right? It says basically that the number of transistors on a dense integrated circuit doubles approximately every 2 years. And this might look like a linear line. It isn't. It's actually going up. It's exponential. That means the possibilities we have change. What?
Stay in the light.
Stay in the light?
Yeah.
Wow.
The opposite of dying.
In the Light is, by the way, a Led Zeppelin song. But anyway, so so where does the light go? I'm out of it already?
Yeah.
Cool. I can use that. Okay, let's stand in the light then. So basically, you all know that the number of transistors changes a lot. That means that the possibilities we have, they double every 2 years, right? And that's enormous. You don't realize that until you say, well, you know what, we now write cloud-native web applications or cloud-native whatever applications, or we do IoT. That's basically only possible because of the fact that everything doubles every 2 years. The possibilities, they begin to get enormous. I'll give you some examples of that. And if you look at another graph, it's actually getting even worse. See, this is the change that we're looking at. They invented like the printing press in the 1400s, right? And it took them 200 years to get to the telescope. Now that has changed, right? So you figure, oh, we can print something and now we can look at the stars. It took 200 years. What do you mean 200 years? Things change now like every 2 months. If you're in the JavaScript world, you know that, right? There's new frameworks coming up like every week or so. I haven't even looked at Angular 5 yet, so I don't know. But it changes all the time, and it changes faster and faster and faster and faster. Do you still remember when 3D movies came out? Is that like 5, 10 years ago? I don't even know. Right? It changes really, really fast. And that, actually, we do that, by the way. Also, it influences us in the way we work a lot. I'll give you an example. So, back in 1981, I think it was, or 1980, I don't remember exactly, IBM came out with this computer. Just as an example of how fast things are going. Right? This is like 35 years ago. If you look at the specifications for this particular computer, it's really nice, right? It says the simplest configuration that has a 16K on board. 16K memory, right? So what does your phone have? Like 128 gigabytes? We had 16K back then. And we could literally program on this. That's pretty cool, right? And it used an audio cassette. Most of you don't even know what that is, right? It's technology that has changed already. You know how you had to use a pencil? For the older people, they know what to do with a pencil and a cassette, right? You just twirl it around and it winds and rewinds and stuff. A floppy drive is optional, right? It was for the more expensive editions of this computer, a floppy drive. Most of you will never have seen even a floppy drive or a floppy disk, like the 5 1/4 inch things or the 3.5 little. You don't know what it is, right? It's old stuff. Or it says basically a system for home or school with a memory of 64K bytes. 64K. And you could write programs on that. That was pretty cool, right? And it was priced at $3,000, right? That's an expensive machine back then. You couldn't carry this around. I got my first laptop a little bit later. It was actually not much smaller than this one. But you could program it, and that was pretty cool. And then, of course, the next change came along. Well, there was lots of change in between, but these are really important ones. Like in 2006, Amazon figured out that they could put up a lot of service somewhere in a data warehouse, and you could put your stuff on it. And then other companies joined in as well, right? And basically the fact that we could do that changed a lot, right? If you were a bank before that, you had huge basements full of machinery, huge basements full of iron, full of hard disk and whatever that, and they still have that, by the way. So you had mainframes and stuff. And now, all of a sudden, small companies that didn't have access earlier to very expensive machines now could run software in the cloud, right? That changed a lot. That put up a whole new range of possibilities. That made it possible to automate processes that we couldn't automate before. Like, for instance, in this example. I read this probably a year ago that Microsoft now wants to solve cancer in the next 10 years using AI. We couldn't do that before, right? And it's basically due to the fact that they have enormous computing power to do this, to help biologists and scientists to help them defragment DNA, to figure out what it is. It's huge, huge amounts of computation. We couldn't do that before. The company I worked for, an insurance company, they actually have to renew of the policies every month. You have to pay everything. That process for an insurance company took, at this particular company, because they run a mainframe and it was written in COBOL, and it took 3 days to run. That meant that every month, when they ran the process, all of the other users of the system were locked out. They couldn't work anymore. Now, if that process, they run it over the weekend, if that failed, they had to restart it again on Monday morning, which basically meant that nobody in the office could do anything from Monday to Wednesday. Now, as an insurance company, that is really expensive. So we sort of rebuilt all that software, put it into microservices, put it in the cloud, and then all of a sudden it ran in minutes because we could use very different amounts of computation. Now, those possibilities changed a lot. To give you more example, in the Netherlands, it's a weird picture, but all of these logos are small companies, startups. There's around 3,000 of them. And they are startups alone in the fintech industry. So they build software for the financial industry. Now, what if only one of these 3,000 companies actually is able to build a banking system? So at traditional banks, that runs on mainframes, large computers, written in COBOL, written in C, stuff like that. What if they could build that using modern technology, run it in the cloud so they don't have any hardware with 10 people? That would scare you as a bank, right? If you're a traditional bank, this should scare you, and it does. In the UK, there's actually companies who have done this, who are now a bank who only employ like 30 people, of which most of them are developers, of course, because we change the world, right? That is what we do. Now, as a bank, that would scare me. In the Netherlands, actually, there was an interview 2 weeks ago. This is the CEO of one of the largest banks in the Netherlands, and he says, this is in Dutch, his biggest threat is not the small startups, it's Amazon, right? Amazon has the power to do this too. So does Apple, so does Facebook, so does Microsoft, so does Google. And so do other companies. This is one I read last week. The best low-cost airline in the world, I didn't even know them, but that's probably my problem, is taking on Amazon in international banking. This is an airline starting to do payments, right? That is changing the world. So I'm an old guy, so I started building software a long time ago, a long, long time ago, 35 years. I've been making money with writing code since 31 years or so. And when I started writing code, we always had to make this decision, and it's still the same case, is that you always have to figure out whether to add in the next new feature to your code base or to improve on the quality of your code. You've all been there, right? This is what it is. And usually what happens is that there's people from the business or the product owner on your Scrum team who say, no, we need to build the next new feature. And you're thinking, what? But I want to refactor the code because it's starting to look horrible. And we will not be able to maintain this over the next 10 years because we don't pay attention to our code. But this is what happens at most companies, right? It's that the quality of the code decreases year by year until you get to a point that we're not able to maintain the code anymore, or maintaining the code costs loads and loads of money. Imagine being an insurance company, still having a huge COBOL system with 18 million lines of code in it, in COBOL, and your COBOL developers are aging. They're about to retire. They are, literally. On the door of their room, there's a picture of a dinosaur. Well, not a real picture, of course, but a drawing. So they will retire within the next 5 years. That means we have to slowly get rid of this software. So how do you do that? That is a big issue, right? And the problem is that in the software industry, every project starts the same. Do you know this cartoon? It's a crazy cartoon. It's from the Czech Republic. You should check it out on YouTube. It's called Neighbor and Neighbor. And every episode is basically follows the same pattern. They start off with a brilliant idea at some point in time, and they start doing this project. So in the first episode, they're going to build a fireplace in one of these guys' homes made out of wood. Not the best idea, but so what happens is they figure out there's some flaw, they repair it, they add some new features. They were thinking like, hey, this is cool, we could add this too. Let's do that. Until somewhere in time, the whole thing blows up. It's the same pattern every episode. Now, if you're in the industry, in the software development industry longer enough, you've seen this pattern, right? This happens all the time. The problem is, it doesn't happen at the day you start your project. Not even in the week or the year you start your project. It happens like 15 years down the road. When you're not there anymore, when multiple generations of developers have worked on the system with all of their own ideas on how to do architecture, with all of their own ideas on how to do code, with all of their own ideas about which language to use, right? And it changes all the time. Requirements change all the time. Technology changes, right? We can now put it in the cloud. So your code will break down eventually. And that, in the face of the fact that the world is changing faster and faster, is not a really good combination. So you have to check this out. So you have to figure out what to do. And basically, it's always the same, right? It's too much dependencies will kill you. Remember the story from last year when there was this guy who had some code in the open source, JavaScript open source, and he got into a legal argument with a company called Kik. And one of his frameworks was called Kik as well, and they asked him to rename it. He didn't want to do it. He got angry, and he removed his code from open source. Now, one of these pieces of code he removed from open source was a function of 11 lines of JavaScript code called leftpad. Now, leftpad was used in all of the larger JavaScript frameworks, right? And because that was the case, that same afternoon when he pulled back his code from open source, all of the builds of these large frameworks broke. That is terrible, right? You break down the internet by just pulling out 11 lines of code. That's horrible, actually. If I look at my code base and I look at the NPM modules or the Node modules I have on my project, I don't even know what this shit is doing. Right? There's so many frameworks that I cannot get rid of. I don't know how to get rid of. It's actually, right, there was a guy saying on Twitter a couple of weeks ago, he said, well, I removed the Node modules from my laptop. I swear you that my laptop got lighter. It's that heavy, right? And that is the problem with all of this software, is that we depend on a lot of things. And we have these huge code bases that we can never get rid of anymore. That is a problem in the faster economy that we're in. So what we need to do as an industry, and we're already doing this, by the way, this is not new, is that we are going to move towards a world where everything will be smaller, shorter, faster. The code, the teams, the cycles, everything. And beyond Agile, right? Beyond Scrum, and beyond having systems. I think we're not going to have systems anymore, but collections of small services, whether they're microservices or functions running in on Azure or whatever. They're also very small, right? So this is going to happen. We are going to build products instead of doing projects. And we'll explain that, because I think that the project metaphor is the wrong metaphor for this industry. So that means we should all stop doing projects. Is that a scary thought? No, to me it isn't, but it should be probably for you. We're going to have even shorter cycles. The cycles that you are probably now used to in Agile project. So just a show of hands, who of you is doing Agile projects? Only a few. Don't be afraid. You're so. So what are you doing? Are you still in waterfall projects? Oh, you need to get out there, right? If you're there, if you're in a waterfall project, switch jobs, right? Get away. You shouldn't be there, right? We're going to have even shorter cycles than Agile, but that means you have to move from waterfall to Agile first, right? And the next is, we're going to have smaller teams. I think that what I've seen over the last 5 or 6 years is that my teams are getting smaller and smaller. Even beyond what is said, like in the Scrum Guide or in Agile Guidance. They're going to get even smaller. That's my opinion, right? And then we're going to have even smaller components yet. So microservices or functions or whatever you have, they're going to be smaller, and they're going to have to work together. You're going to have to integrate all of these small pieces, right, into sort of applications. Now, if you can do all this, that means you're going to become in a culture that is going to be continuous. Everything will be continuous. That will change the culture of your companies as well. Because if you are moving really, really fast, it doesn't work for your company HR department to say, oh, you have to fill in your annual plans. One of the companies I work for now, they have that, right? They have annual plans for their employees with KPIs and stuff. And they say, well, oh, you have to fill in what you're doing and what you want to be doing in about a year. So some guy put up, I want to be better. I want to learn Java 9. And I want to know how lambdas work in Java 8. And after 2 months in, the year in, we started moving towards TypeScript, which means being better at Java 9 didn't really matter to him anymore, but it was still in his annual plan. So how do you deal with that? Your HR department should adapt as well. So does the rest of the company. It means your whole culture will move into a more continuous mode. And that is what's going to happen. So first of all, let me try to explain to you that doing projects is the wrong metaphor for this industry. It has never worked, and it will never work. Okay, it will work for very small projects. It doesn't work for larger projects. And to give you an idea about that, I'm going to use this particular model. This is called the Keynote model. It's written down by a guy called Dave Snowden, who was a Welsh professor on the Bangor University. And he wrote this model together with some other people. And this is really a good illustration of how the industry works. So he says there's 4 zones that you can be in. The first one being the simple zone. Now the simple zone says, okay, there's a cause and an effect. And it's really easy to get from the cause to the effect. We can work this out really easily. We can just write the code and done. We've done all these problems in the 70s, right? And then the second zone is called the complicated zone. Now the complicated zone means that if you have some problem and you do enough analysis on that problem, you will be able to solve it, right? So you hire some analysts and you write down analysis documents and you're going to build that. Or you do the design and then build it and then test it, whatever you do. Now, this is the world that most people think we are in as software developers, right? Oh, there is a problem, we can analyze it, and then after a while, we will have implemented a solution to that particular problem. It's not how it works, basically. Because everything changes so fast, and it has always changed faster than most people thought it would. Because everything changes so fast, the technologies change, the operating systems change, the developers change, the architecture ideas change, everything changes all the time. Now, that means you cannot have a linear solution. You cannot say, here's the problem, we'll get there in 2 years, and then deploy it into production, and it's done. It doesn't work like that in software development. And it has never worked. There was a huge parliamentary inquiry in the Netherlands 2 years ago, 3 years ago, maybe even 3.5 years ago, about all of the major IT projects done by government in the Netherlands. They investigated 37 projects. Out of these 37 projects, they were all waterfall projects, by the way, they all failed, all of them. And then, interesting story is they asked me to come and talk to them, the parliamentary inquiry committee, and they said, could you come and talk to us about Agile? And I said, sure, why not? So I talked to the CEO of the company I was working for, a large consultancy company, which I mentioned earlier, which I probably shouldn't have done, but anyway, so I went to the CEO and I said, this sounds like a good idea because it's our opportunity to change something about how these projects are run. And he said, yeah, that might be a good idea, but we are probably in half of these projects. So maybe you should do this. That's when I quit, actually, by the way. So the thing is, we have never been, and we are not in the complicated zone. Because the complicated zone still has predictability in it. And if there's something we know about this industry, it's that it's unpredictable. It's very much unpredictable what we will be doing in 2 years' time. That means that you are at least in the complex zone. The complex zone means, okay, there's a cause and there's a result that's probably in the same space. And we can set out a direction about how to get there. But we can only take small steps. Taking a small step, trying it out, figure out whether that worked, using a particular technology, see if we can get it together, right? Oh, it works. Let's continue. If it doesn't, we have to change path and then move forward again, which means that after 2 years' time, we will have followed our path, which goes a bit like this, and we will end up sort of down there, but not exactly at the point that we want it to be. We don't know how to get there, actually. I've never seen a waterfall project that actually implemented all of the requirements that were stated up front. It never happens. And the reason is that things change all the time. So we have never been in the complicated zone. We have always been in the complex zone in this industry, which means it's very much unpredictable. That means there's lots of stuff that you can actually stop doing, which is a good thing, right? There's lots of stuff in the industry that we should stop doing, like this one, for instance. This is a horrible thing, right? We've all been here, right? In these projects that have to be predictable, it's the iron triangle that says, okay, given a certain amount of resources, usually they mean people, given a certain amount of time, certain amount of money, we can actually implement these requirements. And that never works because of the fact that there's always changes. And if you take into account that there's always changes, which is basically said in the Agile Manifesto, right? You're responding to change. If you do this, you should stop doing these projects like this. You can also say, all these detailed plannings that people have in projects, just throw them away because they don't make any sense. It is very hard to predict stuff that will happen in 4 months' time. You can sort of predict the first 3 months of what you're doing right now. But after that, just leave it at the high level, which means all this planning and this detailed planning, and people doing that, by the way, you can actually remove them from your project. It was scary. I was doing an Agile masterclass in Rome 2 weeks ago, and I had a room full of project managers. So you're all developers, right? Is everybody here a project manager? Oh, goody, goody. Nobody here. That is good. No ties. Anyway, so I was doing this masterclass in Rome, and I explained to people that you only need the people in your projects that actually do the work. Meaning developers, testers, UI experts, operations people, the occasional analyst and stuff like that. And then one of the project managers says, yes, and a project manager. And I said, no, not a project manager. I haven't had a project manager in my projects for the last 6 to 7 years. And it works out fine. We're not worse off than when I still had project managers on my project. We're doing fine without them. That means we don't have any spreadsheets anymore, but who cares about them anyway, right? So the thing is, what you should probably do is move to this picture. You've probably all seen this picture, right? This is the picture of the MVP. You should build products instead of do projects, right? That means if you have 100 requirements in a traditional project, you would say, oh, I would have to build all of these 100 requirements to the full detail, complete and finished. That means you will have built like 100 cars. But you could also say, if you could talk to your a product owner or your client, what if you could say, you know what, we'll pick up the first one and we'll build it. And what version do you want us to build? Do you want us to build a very easy version in 2 days, like the skateboard version? It will get you from A to B, right? If that is your intention, it will do that. And you could say, we're going to build the fully featured version with an audio system implemented and an AC in it and stuff, and we'll build a car for you. It will take like 4 months, probably, cost you a lot more money. Now what if the client would say, oh, build me the skateboard version of this particular feature. And then, after you're done, after 2 days, you'll build the next feature. And again, you can talk to the client and say, do you want us to build the skateboard version or the bicycle version or the car version? Whatever you want, just name it. That means you're not working from a planning anymore. You are now working from a roadmap. That means it's a list. You don't even have to sort it. You can just pick up the next item from it every time, again and again and again. And you will be working from roadmaps rather than having plans. Now, if you do that, the question actually I learn this to my teams every time again and again. I say, like, okay, the question you should ask continuously to anybody who is demanding a feature or a change or a bug repair, whatever it is, always ask them the question, do we need this now? Because if that isn't the case, then there's probably something else that you should rather do. Something that has a higher sense of urgency, adds more business value, whatever that may be, or that you just need to put in place first. And that you can do if you work from a roadmap. And that will change your perspective on projects. It also means that you can stop doing estimates. Because, as you're probably all aware of, your estimates are usually way off, right? Has anybody done any decent estimates of this year? Who has? Right? That's 3. 3 people think they did a decent estimate this year, right? So why are we doing these estimates anyway? And the funny thing is, if you work from a roadmap and the items on the roadmap are small enough and you have enough of them, you could stop estimating. Wouldn't that be cool? And you can do that. Well, and it's thanks to this theorem. Basically, this is the law of large numbers, and the law of large numbers says, I have to read it. Oh, I didn't bring my reading glasses. It's a theorem that describes, I could read from here, that describes the result of performing the same experiment a large number of times. According to the law, the average of the results obtained from a large number of trials should be close to the expected value. Now, as a result, what this means is saying, if you have a scale, let's say from 1 to 5, and you estimate 100 items on that scale, what do you think on average the outcome will be? The outcome will be 3. On average, right? And if the number of trials, the number of estimates you create, the number of individual items you estimate is large enough, that means you can just pick on the average. So I stopped estimating with my teams a while ago. Well, we do an estimate. We all estimate every work item at the value of 1. That's enough, right? You can just count them. That works pretty much the same as taking all this effort to estimate these items. So you could stop estimating. Now that saves a lot of time in projects, right? That basically means if you're building products, you can stop doing projects. And in these building projects, you're going to use even shorter cycles than you already know. If you're doing Agile, most people will have a 2-week iteration or sprint, or a 3-week or a 4-week, maybe 1 week. And we will go to much shorter cycles than we do now, because everything is going to become smaller. So that means if you do Scrum, Scrum has sort of this heartbeat of usually 2 to 4 weeks, and basically says at the end of every sprint, you know what we'll do? We'll actually ship something to our customers, which doesn't mean you put it into production, but it is a potentially shippable product increment, as they call it in Scrum, every 2 weeks. Now there's some issues with that, but I'll explain that later. First thing is, what I see a lot of companies now do is they are doing, this is a phrase I don't like really, it's called agile transformations. Large companies that sort of want to move to Agile, I'm not always even sure if they even want to move to Agile, but they call it an Agile transformation, which means they're doing Agile much bigger than it was intended to, much bigger than it was ever invented for. So what if you're doing enterprise Agile? Does that mean you're doing lots of Scrums, and then you have the Scrum of Scrum meetings, or you're doing less, which is sort of enterprise Scrum, or maybe you're doing SAFe? Is anybody of you in a company that tries to implement SAFe? Good. Nobody is. It's because you're not there yet, or you're trying to skip this. Either way, it's good. Anyway, so this is an enterprise Agile framework. It has nothing to do with doing Agile software development anymore. It's basically, well, to put it impolitely, a way to pay consultants money to do some stuff in a company. That is not very polite, I know. It also has the metaphor of a release train. Now, trains run on rails, right? Rails are not really flexible. It's not that you can say, oh, you know what, now we're running to city A. Oh, you know, halfway we'll run to city B instead. That's not how it works. So this has nothing to do with Agile. Or you might be even implementing the Spotify model. Is anybody doing that? This is a very nice model. It is. The thing is, with the Spotify model, it was meant to supply Spotify. Now, Spotify was and is a fast-growing company. It grew from like 3 people to 3,000 people in 3 years. Now, my guess is that most of the companies you're in don't grow that fast. So that means that, yes, it has very good elements in it. Yes, it's a nice model, but it's not the model that's going to save you. And the same goes for SAFe, and the same goes for Scrum. There is no model that is going to save you. You have to figure out how to do this stuff in your company in a way you like. So that means you shouldn't exactly copy a single model, whether that's Spotify or whether that's the SAFe model, whether that's Scrum or XP. Just combine it in a way that it works for you. And the thing is, if you are trying to move to Enterprise Agile, try to do a small Agile project first. And I've seen a lot of companies that actually move to this Enterprise Agile stuff without doing Agile. That's not the way it was meant to be. So we should move on from that. And I'll give you one example of Scrum not being the right model for a company. And I call it the red sprint pattern. So this is a burn down chart. You know what a burn down chart is, right? Oh, you're very quiet, by the way. I'm not used to that. So basically, this is a team estimating the amount of work they think they can do during this period, which is a month, by the way. So they estimate it, and they put it up on the chart, and then they draw a line, said, to be able to finish all this work that we estimated that would fit inside of a month's work, we have to be there. So this line is sort of an ideal line. Now, as you can see, at the end of this sprint, this is a project that was executed in Belgium, in Brussels actually, and at the end of the sprint, they still had some work to do. Which means either they didn't estimate quite well, or they were just not fast enough, or things changed, or whatever. This happens all the time, right? I'll show you the next sprint they have. This is the second sprint we monitored. They still had some work at the end of the sprint, and the third one as well, and the fourth one, and the fifth one, and the sixth one. That means continuously, there was a project manager, and he said, these guys suck at their work because they don't know how to estimate their own work. I said, well, that might be the case. Also, it might be the case that estimation doesn't really work. And also that your technology is changing all the time, so maybe it's more difficult to do this work than they thought up front. Now, this means at the end of the project, so at this point in time, they only had like 3 sprints to finish the whole project. And they calculated that they did about 100 points every month. And for the last 3 sprints, they still had to do 900. That means that the project was doomed. It was meant to fail. So Agile projects fail as well. And the whole idea of a sprint is basically a small project, a project of about a month, where we estimate the work and we do all the work and we try to get it finished by the end of the month. So they're still small projects. They're smaller, so much better than the one-off waterfall model, but we can do it much better even still. The thing is, I think we should stop sprinting. We could move on, but if you're not in Agile yet, first move to Agile and then do this. We could move on from Agile to take the next step. And the next step will be just abandon doing sprints. Because if you don't do sprints anymore, that means you don't have as many projects to execute. That means you don't have to estimate the work up front. That means you can just pick items from a backlog, a roadmap, or whatever you call it, a list of features, if you do feature-driven development, then you can take just the next one off, complete it, finish it, deliver it, test it automatically, move it into production, next thing. And if you can do that feature by feature, or work item by work item, or story by story, doesn't matter which unit you use, then you can be much faster. And actually, if you look at the Agile Manifesto, which is already almost 20 years old, it says this, right? It says, to satisfy the customer through early and continuous delivery of valuable software. That is what we were meant to do using the Agile Manifesto. Now, this whole sprint or iteration idea, you can actually abandon that. You could move to putting individual items or additional features to your code base into production again and again and again and again. That means you're moving into something called continuous delivery. It means you can go into production much more. Now, if you're thinking, we cannot go into production more than every 3 months or more than once a year, just imagine that going into production with your code base once a year is actually much more difficult, much more expensive than it would be if you would do this every day. Because the amount of work that you need to put into production if you do this once a year is much, much, much bigger, so you need a lot of integration and regression testing on it, than if you would do it every day. If you could do it every day, that means the difference between the previous version in production and this version in production is only very, very small. It's a very tiny delta. That means that Nobody will even notice if you do this, usually. If there's larger features, of course, you notice, but the small features you don't use. If you're a Gmail user if you've been a Gmail user for the past 15 years, or whatever mail program you use, it has changed continuously on the fly without you even noticing. Now, that is the way that companies will work. This is the way it's going to happen. To do that, you need to do continuous delivery. Continuous delivery means that, actually, as Jess Humble says, it's an approach in which teams ensure that every change to the system is releasable. Every change, right? So every change you put into, you commit to the code, to your repository, could go to production. It says, and that we can release any version at the push of a button. Now that would be cool, right? And there's companies actually doing this. And more companies are actually doing this. I'll show you how we do this. We use Jira to monitor our flow, our way of working. And it's not like in a typical Scrum project that you have to do in progress done, because that has a very low visibility of what you're actually doing. So we actually have sort of a flow where our, this is the board from my own team, we actually move them from left to right in about a day or 2 or 3, depends on the size of the item. Some are a bit bigger than the other ones, it doesn't really matter. And when they're done, they're in production. Whether that's technical code, new features, bugs that we solve, or they actually take precedence for the other features that we build. But this is the way we do it. And we use an integrated pipeline to do that. I'll show you the pipeline, actually. I'll skip this one. This is our pipeline. This is what we do. If I put a piece of code into the repository, I check it in, a build runs, all the unit tests run. If the unit tests run, after that, we trigger SonarQube. SonarQube does a static code analysis. It checks for cyclomatic complexity, it checks for untested code, etc., etc. If SonarQube thinks it's all right, we'll just package it into a Docker container. We'll put the Docker container in Docker Hub. From Docker Hub, we deploy it to a staging environment, to a test environment, actually. It's called staging. It's the wrong name, I know. There, we test this little component, because it's usually a microservice, on its own. If those tests are green, it moves to the next environment. We deploy it to the next environment. There, we test the components together. Then, it moves to the next environment, which we call the integration environment, where the old monolithical applications also land, and we test them all together. From there, it goes into acceptance, where we could do some user acceptance. We usually run performance tests on the acceptance environment, and then it could go in production. If I do training courses, I actually do this live with some mock-up feature, of course. I'll just put it in the code base, see the pipeline run. And it runs for like 5 minutes, and then it's in production at the client. 2 weeks ago, a client called us, and he said to the service desk, he said, well, there's something that goes off with one of the features that we had using authorization and stuff. And there was only 2 people left in the team. Everybody went home already. It was late in the afternoon. I was there, coincidentally, and one of the testers was there. We looked at the code together, and we looked and we checked, oh, say, well, this is what's going wrong. I repaired the code. We ran the test internally. And after that, we clicked the button, and it went into production. And the very next morning, because the client had already gone home, we phoned up the client. He said, well, it's repaired. It's done. You now have it. And they were used to having like 3-month releases, every 3 months a release. So they expected something that said, oh, I report a bug now, I'll probably have it solved in like 4 months. Nope, the same day. Now, if you can do that, it becomes actually easier. And it actually changes the way you think about software. You don't think about, oh, I have a release and I will have to be able to roll back. If something goes off, well, we have to roll back the release. No, you don't. You just repair the bug and move on, and you go to the next day and you deploy it again, done, right? You only roll forward, you don't roll back anymore. And that is changing the way you do things. It also changes testing, by the way. I know you're all developers, so you don't like testing, so you don't write unit tests, right? Who does write unit tests? That's too late. Everybody should do this, guys. It's tedious work. I don't like it all the time, but it's very beneficial, especially in the long run. So you should all do that. You should automate your tests, because automated tests give you feedback much faster than manual testing could do, if you even do testing, by the way. Some of us don't even do that. So that means that if you go into testing, this is what traditional testing, this is called the test con. Basically what you see at most companies is that they have very little automated tests, and they do a lot of manual testing work. That's a lot of labor that you should automate. Because if you automate it, that means you can run it every time and time and time and again. There was a developer or tester on my team, and she was complaining that she couldn't finish all the tests before we put something new into production. Now, this is a web application. Actually, when we put something of one of the components into production, it basically broke her session. So she was typing in stuff and checking that with her Excel spreadsheet, and then before she knew it, bang, the session was down. And she couldn't test it. She had to start again. And she was literally crying about it. She was saying, how can I test in an environment like this? Even before I finish my test, you've already put a new version into production. And we said, so how long do you need to test this stuff? She said, like 2 hours. And we were like, in this 2 hours, we will have probably put out new versions of 10, maybe 12 components. So you should basically be working on automating those tests instead of running it yourself manually. Because if you automate it, and it's a lot of work, I know, you can run it in like 2 minutes. That means you can actually keep up. And you have to keep up because we have to move faster. So it actually should be more like this. It should be more that you write a lot of unit tests, because unit tests gives you the fastest feedback. As soon as you check in your code into the repository, it will run all the unit tests, right? So you immediately see if you've broken any code. And this is what you want to see. So testing should be automated as much as possible. It's the same with your infrastructure. Setting up machinery, I had to have a picture of a kitten in my deck. It's mandatory, I know. And setting up and treating your infrastructure as pets, like, oh, you know, we're going to patch the machine. Oh, something breaks down. Oh, we have to install a new version of this or that or whatever you do, and you keep it running as long as possible because that's the machine that runs our integration test. Stop doing that. Automate it as well. The machines they're no longer in your own company. They're running somewhere in the cloud. And whether that's the Google Cloud or Azure or AWS, doesn't really matter. It's basically you can start up a new machine fully installed with everything by running a script. And you should do it like that, because that will give you what we call immutable infrastructure. It means that the machine it's running on, if the machine doesn't work anymore, we'll just kick it off, give it a small injection so it dies, and then put up a new one just by running a script immediately. So a new machine should be up in like 5 minutes, right? That is changing perspective as well. That means the people who can actually do this, the operations people, the DevOps people as we call it these days, they should be on your team to automate this as well. You should automate most of the stuff you have. And then you could probably move to things like, I don't know what, one-day sprints, no stand-ups, just talk to the teams and build something, test it out, run it, next day. That should be your iteration, right? And then you can stop doing projects. So, 2 more topics to go, basically. I'm going to shortly talk about teams. Teams will be smaller, I think. This is a team of one of my projects a couple of years ago. And it basically had 10 to 12 people in it. They were working on the same thing. It was an agile team, worked quite well. And then we moved them to, so what's the limit on an agile project? If you look at what most people say about Scrum, it's like you have 7 people plus or minus 2, or 6 plus or minus 3, depending on who you read about it. That's the size of your team. That's a number of people that should be in a team. I actually worked for CEOs that said, we had teams of 12 people, 13 people. They said, no, they're too big. They should be 7 plus or minus 2. I said, yeah, but I have 12. So what? What's the problem? If the team thinks they can do the work with like that the best, let them do that. And that also changes perspective. That also changes the perspective of your CEOs and your management teams, because they will actually move the teams to be more autonomous. Because meaning more autonomy means taking responsibility for the stuff you do, which basically means the work is more enjoyable, I think. This is a bit beyond what I was looking for. If you look at what companies are now doing, they're sort of like setting up environments as if it is your own home. The people on my current team, actually, they're bothered with that. They like having a desk with 2 screens on it. So it's all nice, all these couches in the office and stuff like that, and I like it a lot, but I am like that. The guys on my team, they're not all like that. They're now buying noise-canceling headphones because they don't like all the noise in the room they're working in, which is a room full of enjoyment, not like this, but it's nice and it has posters and we can sit on a couch and stuff like that. And they don't like it. They just want to have a desk. So you could go too far, like this picture. This is my girlfriend's leg. in a meeting where she's meeting with a top-level CIO of a large company in the Netherlands in a room that is filled with little balls up to here, right? That's just this is not IKEA, by the way. This is just an office somewhere in the Netherlands, right? And I thought it was, I said to her, don't go work there. Even though it's an innovative company, it's a nice company, but this is beyond what I like. And we shouldn't overdo this, I think. Though we should give everybody its autonomy. Meaning, a lot of people who are used to just doing the work as they're told, it goes out of their comfort zone, right? Not everybody likes to do this. So you should take very small steps in going there, in going to more autonomous teams. The problem is, nobody knows how to do that, right? And it's a bit like this. It's like saying, oh, you have to be more autonomous? You know what? We just need to draw an owl. That means draw 2 circles, and then you figure it out yourselves. That is basically how it goes in most companies. It's very hard to make these teams more responsible for it. And the thing we figured out is this, is that if you give them less rules, they'll become more autonomous automatically. This is a nice experiment. This is a crossroads in Amsterdam, a very busy crossroads. And what they did is they did an experiment. They switched off all the traffic lights. They removed all paint from the roads, and they just said, figure it out yourselves. And what happened is that the behavior of the people crossing this crossroads really changed. They started basically communicating with the other people on the crossroads. I know we're IT people, we don't like to communicate, all true, but if you remove more rules, people have to figure out how to do stuff themselves. They have to start talking to the people next to them. The other people crossing the road as well. You have to look into that. And that means you have to start communicating. And that's an important aspect of what we do, I think. And then I saw that my teams were really starting to change. In a waterfall project, you have these different teams in different disciplines. And then we moved to Agile. And Agile said, put them all together in the same team. Create multidisciplinary teams. And what I now see happening, but I'm not sure that's everywhere, is that I have a team of like, it's currently like 20 to 21 people, and they're all in the same team. They actually figure out themselves how to work together. And it changes all the time. With every feature we pick off the backlog, we pick off the roadmap, what happens is that they'll pick it off and then say, oh, you know what, can you help me out because you're good at this stuff? 2 people sit together, maybe 3 people work together on that particular topic. And when the topic is finished, they sort of change again. They hook up to other teams, or they figure out a new team to build a new feature. And it goes sort of, it's like organic. I don't like that word really, but it's sort of organically. It's like people move from team to team every time again and again and again. And this sort of seems to work well for them. So basically what it allows them to do is to continuously learn. They'll learn stuff every day. What we actually did at this particular company is that we added personal boards to Jira for every one of the people in the teams. And they put up the stuff they want to do. They want to go to a conference. They want to learn how to do Kotlin. They want to learn how to do whatever, TypeScript, or learn how to program Angular, whatever they want to do. Or read a book on Java for testers, which one of the testers did on the team, right? And they have their own way of growing. And it means, again, stop doing these projects. One last topic I have. It's a small one, but I know you're probably already aware of this, so I kept the technical part a bit to the end, is that to be able to do this, to be able to do continuous delivery, to be able to do even domain-driven design right, to be able to work on very small pieces, that means you also need to deliver software in small pieces, in small chunks. Not anymore these huge, large code bases where everything depends on each other, but move into getting a very much more, let's say a more modular approach to writing your code. Microservices do that. The problem is with microservices that, oh wait, I'm going to skip these ones based on time, is that the problem with microservices is that it is not easy to get there. I helped a bunch of companies going there. It took a couple of years before they got to the point that they could actually deliver very small pieces. And we have to get used to this habit, right? It's like every time we get the chance, we will rewrite the code. We will do that all the time. Now the funny thing is, if all your code sits in very small chunks in microservices in their own repositories with their own build pipelines, you can actually do this or not. We can actually rewrite a new version or write a new version of any of our components, let's say within a week, fully tested and integrated in the rest of the landscape. We could do that. If we want to try out a new language, we can, right? But, as said, microservices are not easy. If you look at Martin Fowler's short definition, that's what he says, short definition, you have to take care of all this stuff before you get there. It is a very different architectural style. Yes, it is about developing an application as a suite of small services, all very modular. And whether you actually break them down or put them in different modules in the same code base, I don't really care. They're all running in their own process, which means they can scale up. They're communicating with lightweight mechanisms. Usually it's HTTP or HTTPS. Having an API, so you have to think about API design as well, about your endpoints, about your HTTP status codes, and all that stuff. And they're built around business capabilities, independently deployable by fully automated deployment machinery. That is what you need to set up as well, right? So you need to get the infrastructure people on board to do this as well. So the teams doing this are actually going to have more disciplines, and these disciplines will split up into smaller teams. That's the way I see things happening at my teams. And whether you do monolithical applications or microservices, it depends, right? It depends on whether you are coming from a large code base, moving it into smaller pieces. In those cases, maybe just putting it in a more modular structure will already help you create more maintainability, create the ability to release more often. Or that you could actually break it up into small parts and actually run them in their own process and make them independently deployable. It depends, right? Both scenarios are good. It's just when you get to do more frequent deployments into production, that is what makes it better. Okay, so, and then of course, everybody's talking about serverless computing now, which is basically not very much serverless. There's always a service it runs on. It's somebody else's computer, basically. But the functions are going to get even smaller. You can now deploy individual functions, which makes integration probably even harder, but the chunks of code become smaller and smaller, which makes them able to deliver much faster, right? So that's basically where we, I think, are going. By the way, all of these systems that you're now building are distributed systems, and that makes it even harder, because building a distributed system means that if you have like 100 microservices all running their own database, being responsible for their own data, how do you deal with transactions? There are no transactions anymore. They're gone. You have to figure out different mechanisms to do that. But the thing is, once you figure this out, and you will, to move to smaller modules, smaller piece of code, microservices, maybe move into serverless computing, you'll be able to deliver faster. That means you'll be able to stop doing projects. Now, to wrap it up, there's a couple of things that you need to keep in mind, I think. One of them is that we are not in the complicated zone. Doing projects, thinking it's plannable, thinking it's predictable, it is not true. We all know it, we just don't act about it. We should. We should realize that in the Knaffen model, we are in the complex zone, not in the complicated zone. So that means you have to stop doing projects. You have to stop doing waterfall, because it really doesn't work. There's so much research being done about waterfall, it always fails, right? Okay, there are some projects that might be successful, but if you move to shorter cycles, research shows that the percentage of successful projects, if you do projects, actually grows a lot, right? So stop doing this. Stop thinking that you can't plan things. Stop doing projects, after all. Move to building products, whatever they are, and build them in very short stuff, in very short cycles, in very small pieces of code. Because in the end, we are the ones that are changing the world, right? I saw a video of a robot making a backflip. Did you see that? Yeah. And everyone was like, oh, that robot is amazing. No, he's not. It's the programmers who did this who are amazing, by the way. We are changing the world, we as developers, right? We have the ability to go faster and faster and faster and make it better. And you need to, because if you don't, your competitor will do that. And then the most important part, and that's basically why I'm in this business, is because I love it so much. And there's not a single business out there. My son just told me, he said, this is probably the only field that people can actually talk about the whole day, even at breakfast or at dinner, still talking about how to code stuff, still talking about technology. That passion is unique. And it makes us the best industry to be in. So, thank you for having me. I hope you will enjoy the rest of the conference.